So I'm going to skip over some stuff. Obviously, if we're on page 279 in our notebooks, that we are definitely skipping over some things. So what I'm gonna show you just for, it's gonna take me like 3 minutes max to show you what we're skipping over. We will probably assign on Friday a Desmos activity that is self-paced that you guys can go through to do what we skipped over, okay? I didn't show last year, or we didn't do those lessons last year in Algebra 2 Trig either, so it was something I skipped last year and I assigned some Desmos. So what we skipped over was what the graphs of sine, cosine, tangent, cosine, and cosecant, or cosecant and secant look like. So I'm just going to put one into Desmos. There's the graph of sine, okay? The big thing you got to know about graph of sine is that it starts at 0, okay? Now I'm going to put in the graph of cosine. Look identical, okay? Except that the sine starts at 0 and the cosine starts at 1, okay? Guess what? We can move them up and down, right? So if I just go, just like we do anything else, let me turn that one off. I just moved it up, right? I just added 1 and moved it up. I could move it down. Let's subtract 2. It got moved down. Just like we've done the whole rest of the year with parabolas and absolute values and exponentials and everything else. We can move them up. We can move them down, okay? You can move them left and right. That's what we call a phase shift. I don't tend to get into that. I think it moved a little bit, right? Let's see. Let me put sine in here. Sine x. That's what the, oh, I turned it off. That's why. So see how the red one is shifted from the blue one. It went to the left or the right. You can also, the blue one's now my original. We can also make them taller. So we can stretch them. Okay. We can compress them just like we did any other graph. Okay. Let me go back to, okay, so sine is my original. So now let's see what happens with cosecant. So sine and cosine, very similar. They're just, one starts at 0, one starts at 1. Cosecant, notice it's the reciprocal. If you thought of this as like arc as like a little parabola, okay? And if you think about flipping the reciprocal, look, you now have the cosecant graph, okay? And in between here, you know how on the unit circle we've gotten places where it's undefined? Well, in between here, there's what we call asymptotes. And I know we didn't get into asymptotes because we didn't graph rationals this year. We will definitely be talking about more of that in the fall. But there's asymptotes, lines that it gets really, or kind of parts of the graph, or invisible and vertical lines that it gets really, really close to but never crosses, help us graph. But we'll never ever get across those lines. Well, those asymptotes are there and they just help us. That's where it's undefined, okay? You'll notice I'm going to switch this to cosine. So cosine, and its reciprocal, or secant, have the exact same relationship, okay? It was hairspray. That's right, Stephanie. So they have the same relationship as sine and cosecant, okay? And then this is the one that drives everybody crazy. So let me just put in tangent really quick just so you can see. When we do this one on the graphing calculator, it tends to zoom it in more and it looks kind of like a heartbeat, but that's what a tangent graph looks like. And just to compare it, that's what a cotangent graph looks like. So it just flips the other direction. Just so you have an idea of what it looks like, okay? Because we're going to see pictures. We're going to work with the inverse trig today. So you're going to see pictures of the inverse trig. So before I get in there, so you can compare, okay? Here's the graph of sine. Let's see if it'll do the graph of sine inverse. I haven't tried this yet. So this is, oh, there it is, okay? So do you see how the graph of sine inverse only does that little tiny spot, okay? That's because there's a domain restriction on it, meaning that it's not valid for all values. It's only valid for that little tiny spot, okay? I'm going to switch it to cosine, okay? So there's the original cosine graph, and cosine inverse looks like that. It's restricted, and it's restricted in different places than sine was restricted in. And then let's do tangent, because we're only going to work with those 3. That's what the original tangent looks like. That's tangent inverse. Again, there's some restrictions, okay, on it. It looks a little bit, it looks like that one has the most availability, as so to speak, okay? All right, I am going to go ahead and go into OneNote, and we're going to go ahead and take our notes. We're only going to do the first 7 examples on this, so it should be hopefully short and sweet. I am going to flip this. I don't know what happened here, little faces. I don't have my grid on, that's why. Okay, and I'm watching the chat at the same time. Okay, I'm going to flip this, and we're going to go through this real quick. So our official essential question for the day, I'm going to hit hide there, is, we'll go green. How do you evaluate the inverses of trigonometric functions? So how do you evaluate the inverses of trigonometric function? I'm not spelling that right. I'm going to sneeze. Trigonometric. I'm still not sure that's spelled right. Functions. I'll give you a minute to write. Okay, so first thing they give us is the definition of inverse of the sine function. So the inverse of the sine function is defined by y equals arc sine if and only if y equals sine. So really what's going on here is if you have something like this, okay, and I want to reverse that. I want to do the inverse of it. I don't know what just happened. Go away. That means I would take the sine is the inverse of it, of both sides. Well, sine, I would end up with sine of y equals, and then these guys cancel, so x equals the sine of y. So that's what they're seeing. And we can reverse it and do it the other way as well. If we're trying, we saw that when we were solving for angles last week. If I have something like y equals the sine of x, and I want to get rid of the sine so I can solve for the x, I can do sine inverse or arc sine. They're interchangeable notations. You're going to see them both, and these guys would cancel, and I would get sine inverse of y equals x. So that works for no matter which trig function they give us. Our text is going to focus on the sine, the cosine, and the tangent. Okay. And then they did give us some information about the domain and the range of it. So that's really what where the restriction is, and it's not it is a domain restriction, but it's really the range that was where we where it falls into what we need to deal with. Okay, so if I put my unit circle over here so that we could see it, and you should have a little box that says quadrants. So it's, for me and my brain, it's easier to remember which quadrants each one of these things is valid in. Okay, so it says I've got to go from negative pi over 2 to pi over 2, and we've talked that we can count in the opposite direction. Okay, so if I just go one pi over 2 back, that's like saying negative pi over 2. And the reason we do that is because this way we have a smooth place to get all the way from here all the way up to here, and we can count in order. Because it doesn't make sense to go from 3 pi over 2 to 5 pi over 3 to 7 pi over 4 to 11 pi over 6 back to 1 pi over 6. That counting doesn't make sense. So we use the negatives. So usually you have your unit circles and I have you add the negatives on there. If you do have a picture of it, go ahead and add the negatives on. This would be negative pi over 6, as well as being coterminal to 11 pi over 6. This would be negative pi over 4. And this would be negative pi over 3 and negative pi over 2. So now I can count, and it makes sense. It's like being negative 1/2, negative 1/3, negative 1/4, negative 1/6, 0, back to 1/6, 1/4, 1/3, 1/2. That makes sense. That makes sense to count it that way. It doesn't make sense to use the other numbers. And so we know that for arc sine, we are only valid in quadrant 1 and quadrant 4. So I'm only allowed to use values I'm only going to use these radians and these coordinates if I am talking about sine. And the reason is that you've hopefully noticed that the coordinates are the same, right? They're very similar. except that there's usually one positive and one negative coordinate. So that way there's only one radian measure that we can get back to if we're doing an inverse trig. So I remember that arc sine is only valid in quadrant 1 and quadrant 4. Okay, I'm going to erase my scribbles a little bit. Okay, then arc cosine, because I know that the other thing was I knew that sine was positive here and negative there. Okay, if I'm talking about arc cosine though, or cosine, I want to have a quadrants that are next to each other where I have one where it's positive cosine and one where it's negative cosine. Well, I know in quadrant 1 it's positive cosine, which is the x value, and then it's negative in the x value in quadrant 2. So for cosine, we use quadrant 1 and quadrant 2. And then for arctangent, again, I want quadrants that are next to each other where I have a positive value and a negative value. So we know from all students take calculus that that the tangent is positive in quadrant 1. It's technically negative over here, but we tend the domain that they put on us is they want us to go, or the range they put on us is they want us to go here. So we know that tangent is negative down there. I don't know why I wrote a -1. So we're going to, for tangent, we're also going to use quadrants 1 and 4. Okay, and then there's the pictures of them. We kind of looked at that a little while ago. Okay, so I need to find the exact value of each expression. Okay. So what we're really looking for is we're looking for the radian measure. That's what our answer is going to look like, is a radian measure. Okay. So, and again, we're only going to do these 7 examples because I know some of you have a test that you have to be getting to. So, so in order to reverse arc sine, we're really taking the sine of both sides. So I'm going to rewrite this a little bit. Okay. Because I'm trying to set you up for what you're going to see later on. So really, I'm going to write it as y equals that. So just add a little y equals there. And then I'm going to go another line, and in order to reverse arc sine, I'm going to take the sine of both sides. So sine of y equals sine of the arc sine of -1/2. Okay. So we know that these two would cancel, and I'm really looking for where the sine of y equals 1/2. All right, so that means I really need to look for a 1/2. I know I'm only valid in quadrant 1 and quadrant 4. So I'm looking for a y value of 1/2 in quadrant 1 and quadrant 4. Well, I'm looking at the y values. Ooh, I see one right here. I'm looking. There's only going to be one place where that's true. So that place is pi over 6. So we would want to say, if we were going to use this notation that we added in here, I would say that y is equal to, should have probably used theta, pi over 6. Theta would have been better because theta means angle. Okay. All right, let's try it again with this one here. This one says sine inverse instead of arc sine, same thing. So I'm going to say theta equals, and then I'm going to take the regular sine of both sides. So sine of theta equals sine of sine inverse of the square root of 3 over 2. So we know these two would cancel, and I'm trying to find where sine of theta equals square root of 3 over 2, which I did not write very well. Okay, so I'm going to erase what I did over here. Again, we know that sine is valid in quadrant 1 and quadrant 4. So I'm going to look for a y value of square root of 3 over 2, which I see that y value right here. I know it's only going to appear one time because I'm not using this half of the unit circle. So my radian measure there is pi over 3. So theta would equal pi over 3. All right, I don't see any questions in the chat. Okay. All right, I'm going to look at this next one again. I'm going to pretend it's y equals. So I'm looking for I'm going to take the sine of both sides. So sine of y equals sine of sine inverse of 2. And these guys cancel, so we got sine of y equals 2. So I'm looking for my y values, again, in quadrant 1 and quadrant 4, where I have a y value equal to 2. that doesn't exist. Okay, so on this one, we would say that it's outside the domain. Okay, so or we would say it's undefined. So this is undefined because it's outside the domain for sine. If you look at the domain for sine, it said that it had to be between -1 and 1. Okay, because outside domain for sine. And that did not look very good either. Okay. All right, we're going to do the same thing now. We're introducing cosine finally. So again, I'm going to rewrite it, and I'm only doing this. I'm going to use theta. I used y last time. Should have used theta. So theta equals that. And I'm setting this up in this manner only because you don't have to do it this way, but just to kind of so you can kind of see that sine and arc sine, or arc sine and arc cosine reversing each other. Okay. So I'm going to take the, I'm sorry, it's cosine and arc cosine. So I'm going to take the cosine of both sides. So the cosine of theta equals the cosine of the arc cosine of square root of 2 over 2. So again, these guys cancel. So I'm looking for the cosine, where the cosine of theta equals radical 2 over 2. Now, cosine is valid from what we learned earlier in quadrant 1 and quadrant 2. So I'm ignoring the bottom part of the unit circle. And I'm going to, oh boy, come back. Okay. And I am going to, so I'm looking for where, again, this time it's an x value, x part of the coordinate. So I'm looking for where the x part of the coordinate is positive square root of 2 over 2, and I'm reading that matching corresponding radian measure. So my radian is pi over 4. Okay. I am going to do a similar thing here. So I'm going to say that theta equals cosine inverse of -1. So in order to undo cosine inverse, I know I have to take the cosine of both sides. Okay, so I'm getting rid of that. So I'm looking for where the cosine of theta is equal to the x value is 1. Again, I'm looking in quadrant 1 and 2, and I'm looking for the x value to be positive 1. Now, in that case, we don't notice it doesn't start at, it goes from 0 to pi. I don't get to use 2 pi, so I only can use the 0. So I know that the angle measure that I'm using there would be 0. And I'm sorry that that is not written on me. I really should have that radian measure on there, huh? All right, so here's where it gets tricky, is with tangent. This is the one where you've got to work with it just a little bit more, okay? I am going to erase the scribbles on my circle. I'm going to probably work in a different color so it separates it a little bit. So I'm going to still go theta equals arctangent. I'm starting it the same way as the others, arctangent of 0. So I know I'm going to take, in order to reverse arctangent, I'm going to take the tangent of both sides. Okay, so I know these cancel. And I am looking for where the tangent of theta is equal to 0. Well, I know I can't just read that off the unit circle, but I do know that the tangent of theta is the sine divided by the cosine. Well, I know that this denominator has to be a 1. Okay, it can't be a 0 or it would have been undefined. So I know that that means that the sine coordinate or the y coordinate has to be 0 and the x coordinate has to be 1. I also know if it's tangent, I have to find that in quadrant 1 or quadrant 4. So I'm looking for the coordinate 1, 0. And I find that right here. And again, I can't use the 2 pi. I have to use the radian measure of 0. So my theta again here equals 0 radians. And notice I'm not putting degrees on it because we have transitioned into it's only working with radians. All right, we're going to do one more. So theta equals tangent inverse of -1. Okay. I'm going to reverse it by taking the tangent of both sides. Okay, so those are gone. And I have the tangent of theta equals -1. All right, so I'm going to go to, so again, tangent means I need to do the sine divided by the cosine, which means I have that going on. I have to get a -1. So basically that means I need to have an x coordinate and a y coordinate that are exactly the same but with opposite signs. So I'm going to look through there. An x-coordinate and a y-coordinate that are exactly the same, but with opposite signs. So look at those two. The x and the y are exactly the same. We just need the signs to be opposite. So look at this one. The signs are opposite here. Oh, I erased my negative. I have to read it in the opposite direction. When we're counting it, we have to use the negative radian measures. So it should be negative pi over 4. So let me reverse the thinking on that. I'm going to write it over here. So I know that my cosine is square root of 2 over 2. That's the cosine. And the sine is negative square root of 2 over 2. So that means if I were to reduce this, remember these would reduce, this would reduce. So when I cross it out, it's going to be -1. So that means that my angle measure, theta, has to be, and I read in the negative direction, negative pi over 4. Okay, you got any questions? Andy, do you have some jokes for us? Oh, he's excited. He just came back in because he was working on stuff. A lot. Did you get a lot done in the last few minutes? Yeah. Here, let me go back to here. I'm going to go here. You ready? Quick, because they've got a test to go take. I'm going to stop presenting. Here. Okay, let me go back and look at my example 5 because Pearl's asking me a question. Why? Okay, so in example 5, oh, I have a typo. That's why it changed. I need to go back and redo example 5. So let me fix that. Okay, Andy, come here and tell a joke, quick. Okay. Okay, he's gonna come tell one quick joke. All right, hurry, quick, tell a joke.
Why did the boy refuse to drink the glass with 8 ice cubes in it?
Why did the boy refuse to drink the glass with 8 ice cubes in it? I don't know why.
Because it was too cute.
Oh my gosh, that was amazing. Okay, one more. Quick, you have another one? All right.
Wait, I think I do.
Okay, he thinks he does. He's avoiding work with his dad right now, so he's got to hurry. All right, I need to go back in and I need to present again, and I got to fix this one. Oh yeah, quick, hurry.
What's a bird's favorite type of math?
I don't know what's a bird's favorite type of math.
Algebra.
Algebra, that was awesome, dude. Okay. All right, let me fix this. I know some of you got to go and take a test. I get that. Go ahead and take your test. Good luck. Okay. Oh, really quick. Don't leave yet. I haven't taken roll. That's not what I wanted to do here, people. Let me take a picture of roll really quick so I know who. We have to make sure that my class won, right? Okay. All right, I've got roll done. So if you have to go, you have to go. All right, let me fix this problem. I totally messed up. Okay, thank you for catching that. So right in here, I accidentally changed my negative one to a positive one. It should have been -1, which means that my answer was wrong because I wasn't looking at my answer key like I should have been, which means that my x value needed to be -1, which means I'm going all the way over here to pi. So my theta should have been pi. So that should correct it. Are there any other questions, comments, concerns? Pearl, thank you for bringing that up. All right, I have not posted an assignment today, and I haven't gotten with Ms. Rondeau to make sure she is posting an assignment today, but that'll get out there. I'll email when it's out there in the next little bit here. And then yesterday, if you took the test and you're